try recording to see whether it's working or not. It's working.
Yes, sir, it's working.
Sir, do you have the hard copy version of the book or the soft copy?
I have the hard copy.
Sir, the soft copy of the book looks like it is made of slides. Is that the correct version?
Give me a knock after the class. I'll verify. Okay? All right, so let's start with chapter 0, that is introduction to computing. Basically, we'll be just recalling the number conversion system that definitely you have learned. But still, as I said, I will start with very beginning. So already all of you know what is binary number system, right? That is based on 0 and 1. Only there are 2 digits, that is 0 and 1. Second, decimal, definitely you know, that is we use on our daily basis. The numbers from 0 up to 9, total 10 digits. So that is your decimal based system and binary based system. I know all of you know how to convert, but still let's just see some conversion. Okay, so if I ask you that convert this 27 to binary, how do you do that? Without using calculator, definitely. Anyone, just tell me how do you, yeah.
Dividing by 2.
Exactly.
Sir.
We continuously keep on dividing by 2, right? So 27 divided by 2, so you get a quotient and you get a remainder. So if I divide 27 by 2, my quotient is 13 and my remainder is 1. Then I divide the quotient again. Now my quotient is 6, remainder is 1. So 6 divided by 2, I get 3 and 0. 3 divided by 2, I get 1 and 1. Finally, 1 divided by 0, I get 0 and I get 1. All right. So if this is the case, but either way to look the same, but which one will be your MSB and which one will be your LSB?
So the start one will be MSB.
Okay, so the starting one will be MSB. This one then?
No, sir, that is LSB.
Exactly. So this is actually LSB and this is your MSB. So your converted binary will be 11011. I mean, in this way. Is it okay up to this? I think all of you already know this thing, but those
Yes,
who
sir.
don't know or those who have forgot, I think this is okay. We'll see another example. Let's see another example. Let us convert 125. So 125, let us have a quotient and a remainder. So divide 125 by 2. So what will be the quotient? 62, right? 62 by 2, once again, it will give you 31 and 0. 31 by 2, it will give you 15 and 1. 15 by 2, it will give you 7 and 1. 2 will give you 3 and 1. 3 by 2 will give you 1 and 1. 1 by 2 will give you 0 and 1. All right, now it will be better if you understand. So definitely this is your LSB and this is your MSB. So your binary will be 1 1 1 1 1 0 and 1. So is that okay, everyone? All of you understood?
Yes, sir.
So 125 10 base will be 1 in binary base. All right. So this is how we represent. Okay. Over here we represent the base. So this is on 10 base or decimal number system. This is your binary number system. All right. So far it was quite easy. Now let us do the opposite. That is, now let us go for binary to decimal. Okay. All right. So say I give you a number 110101. How will you convert it to decimal?
Binary into two of power like 1 into 2 to the power 0 plus
Okay. So 1 into 2 to the power 0. Next.
plus 0 into 2 to the power 1.
0 into 2 to the power 1. Yeah, so we are starting in this manner, right?
Yes, sir.
So 1 into 2 to the power 2, 0 into 2 to the power 3, then 1 into 2 to the power 4, and 1 into 2 to the power 5. Fine. So what do we get? So this is your 1 into 1. This is your 1. 0 into 2. This is again 1 into 4. 0 into 8, 1 into 16, and 1 into 32. So if we multiply and then we have to add. So 1 into 1 will give you 1, 0 into 2 will give you 0, 4 into 1 is 4, 8 0 times 0, 16 and
মেসেঞ্জারও আসবে না, ওইটা সব মেসেঞ্জারটা ফেসবুকের সাথে কানেক্টেড, সেটা বুঝতে পারলাম, কিন্তু আগেরটা কি হয়েছে সেটাই বুঝতে পারলাম না।
mute karo bhai. So if you just simply add these numbers, we get 53.
যাদের অ্যাড করবা তাদের সাথে, হ্যাঁ,
Is it okay?
কিন্তু তো মেইন ফেসবুক বলতে পারলাম না,
রাফিদ তোর মাইকটা একটু মিউট কর রাফিদ।
মেইন ফেসবুকের কি হয়েছে ওটা বুঝতে পারলাম না, আর ওটার ইমেইলে কি বলছে এটা না পড়লে আমি বুঝতে পারতেছি না যে
I'm muting.
কি আছে। না,
All right, so 53. So sum up your 110101 binary. If you convert to decimal, you get 53 in plain base. So up to this, I know it is okay. So every time you don't have to multiply these things. Okay, the simple way to remember is the concept of weight. I mean, if you go for concept of weight, these are known as your weights. Okay, these are known as your weights. Every time just remember the weights. It is 1 2 4 8 16 32, and it will keep on increasing on the 2 to the power. So you just keep this number as base, and then every time you can convert. So let us take another example. It will be much clearer. All right, so if we have a number 1011, so I told you that use the concept of weight. So what are your weights? Start from 1. How many digits I have got? I've got 1 2 3 4. So I'll have 4 weights. So 1 2 4 and 8, and just after that put down the digits. So 1 1 0 and 1. Now you can simply just multiply. So 1 1 1 2 0 8. Now if you just add them, you will get your result. So this is your 11. So 1011 base 2 is equal to 11 base 10. So is this one clear to everyone? Have you understood, all of you?
Yes sir.
Sir, will the same happen in terms of decimal value?
I mean, if we go from decimal to binary, is that what you are saying?
No, sir. For example, 1011.00 something like that, sir.
1011 point. We do not have points in this in binary number system.
No, sir. I'm talking about the reverse way, sir.
From decimal to binary,
Yes, sir.
if you have points,
Yes, sir.
yeah, there are some different methods when you have points. And luckily, while dealing with microcontroller, you don't have to worry about points. All are integers over here. Okay. Is it okay?
Yes, sir.
So let's take another example, a bigger one, say 1 1 0 0 1 0 1. So let us go for the weights again. So how many digits I've got? 1 2 3 4 5 6 and 7. So I've got 7. So 1 2 4 8, then 16, 32, 1 2 3 4 5 6. I need another one, and that is 64. So just put down the digits 1 1 0 0 1 0 1. Simply multiply and then add. So 1, so it will be 0 0 4 0 32 and 64. So if you just add them, you will end up getting
Sir, 103.
1 0
103.
No, sir, 101, sir.
101.
101.
Yes.
Exactly. So the binary of 1100101 binary is equal to 101 in 10-base system. All right, I know most of you already know, but please, those who do not know, those who have forgotten, please make sure you understand these things. Okay, these are your prerequisites. You definitely need to understand these things. Okay, now let us apply this same concept of weight to convert from decimal to binary. Okay, the reverse one. Let's say we have got 3910 decimal. Now we need to convert this to binary. So what I said, that we will apply the same concept of weights. All right. So how can we do that? See, so first of all, write down the weights. Okay. While writing down the weights, write down the maximum weight that is just below this decimal number. So if I go to my previous one, you see these are your weights. So the maximum weight just below 39 is 32. So start with 32, then write down the weights accordingly. So next weight will be 16, then 8, then 4, then 2, then 1. All right, now let's give it over here. Okay. Okay, in order to get 39, you definitely need 31. So put a 1 on this. So write 32 and write plus. Now, do I need 16? Because if I add 32 plus 16, it will cross 39. So I don't need a 16. So I will put over here a 0. 32 plus 8. If I add 8 with 32, again it crosses 39. So I don't need a 8. So 8 will also become 0. Next comes 4. Of course, with 32, if I add 4, I'll get 36, which is still less than 39. So add 1. So I'll get 4 over here. So 32 plus 4, I already got 36. Then if I add 2, I'll get 38. So I will add 2, 2, 2. So 32 plus 4, 36, plus 2, 38. And if I finally add 1, I will get 39. So this is your binary format. So your binary will be 39, 10. Will have your binary of 1, 0, 0, 1, 1, 1. Is this one understood to everyone? So this will be 0 and 0.
Yes, sir.
All of you, have you understood this part?
Yes, sir.
Okay. Now let us move on to the important portion. What type of number system does your microcontroller or microprocessor use? We know that your computer works on binary, but what does your microprocessor or microcontroller use?
Binary, sir.
Binary is
So
there.
hexadecimal.
Exactly, we use hexadecimal. When we go for coding, during coding we use hexadecimal, and this is what your computer also uses. They convert hexadecimal to binary. That means first of all they take it in hexadecimal, and then they convert that to binary. Can anyone tell me why it uses hexadecimal rather than decimal or binary or some other system? Why does it use hexadecimal? I think we discussed it in our previous course. Still again, I'm asking.
Because it is a 16-bit processor.
So what is the advantage of no 16-bit processor? No, that is not the correct answer. Because your 8051 might be a 16-bit processor, but there are 32-bit processor or even greater than that. But still they use hexadecimal. Why?
16-bit data bus.
Again, there might be other data buses as well.
Sir, because it's simply more value to represent the data.
can you be more specific?
Sir, in terms of decimal, there are 10, octal, there are 8, but hexa, we have just 16. So we have more provision to.
So we
represent
may
the
develop another system that is more than 16, right? So 32, and we give it a name, say dex or something like that. But we did not do that. We stopped at 16. We stopped at hex. Why?
Sir.
Easy conversion between binary to hex.
Easy conversion between binary to hex. That is an advantage of hex, but that is not the reason of hex. All right, let me say. So when we have our decimal number system, right? So say let's take a decimal number 4. To represent 4, what is the binary form of 4? Tell me. What is the binary form of 4?
100.
Sir, 100.
Okay. What is the binary form of 2?
Sir,
10.
10.
10. Okay. Now you see. Okay, let's go for the highest one. 9. What is the binary form of 9?
1000.
1001, I guess.
Yes, sir. 1001.
So you see that over here you need 2 bits, over here you need 3 bits, over here you need 4 bits, meaning that to represent all the decimal number, you need maximum of 4 bits, right? When we go for 1010, what is that in decimal?
10.
That is 10. See what you are doing. You are using 2 separate decimal digits to represent a 4-bit number, whereas you have already used a 4-bit number. What I'm trying to say is that in decimal number system, we cannot represent all the decimal numbers with 3 bits only. We cannot do that because the largest number we can represent in 3 bits is 7. 7 is 111. This is the largest number you can represent in 3-bit system. So when we go for 4-bit system, I mean when we go for 8, 9, then we need a 4-bit system. So see, in 4-bit system you are using only 2 combinations. Rest of the combination are still unused. You are not utilizing them. So if you go for decimal number system, neither can we make sure that the whole decimal number system is represented by 3-bit number system, nor can we say that we are using all the combination of 4-bit number system. To solve this problem came the hex. You see that in hex we have a total of 16 digits, and these 16 digits utilizes the total combination of 4 bits. In 4 bits you can have a total of 16 combinations. So all the 16 combination of 4 bits is utilized by this hexadecimal number system. Did you guys at least get what I'm trying to say?
Yes, sir. We are using the maximum capacity of the 4 bit.
Exactly. We are using the maximum capacity of 4-bit combination. That's what. That we do not get either in decimal. In binary, it becomes too small. Definitely, we get only 2 digits. That is not very helpful. So in hex, using 16 digits, we get the maximum capacity of 4 bits. All right. So that is the main advantage why we use hex. So let's draw a table. So this one will be very helpful for you. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, since we have hex, so we need to go at least up to 15. So 10, 11, 12. Let me write it. And 15. So you guys know the binary still I'm writing. We'll go for 4-bit. Let me know if there is any mistake because I'm just writing and doing both the things. So there might be some error. Is it okay? The conversion.
Yes, sir.
So you see that we have got 15 numbers. So let us see the corresponding hex number. So this is 0, 1, 2, 3, 4, 5. Okay, tell me what will be this one?
A.
A, then B, C, D, E, F. Okay, one simple question. What is the hex format for decimal number 16? What is the hex?
10.
Exactly. This is 10, remember, okay? This and this is hex. Then what is 17?
1 1
1 1, exactly. So how long will we go in this way?
up to 1F.
Up to 19. Yeah, after 19. So means 19 means if we have decimal, in decimal if you have 26, then 26 is equivalent to 1A. So if we have 25, that is equivalent to 19. Okay. So 1A, then again 1B, 1C, D, E, 1F, and then again 20. All right. So these are the normal number conversion system. I believe all of you already know. Now someone said that the conversion makes easier. This table makes the conversion easier. So you just have to remember the equivalent 4-bit. So that will, from this table, if you just remember the equivalent 4-bit, it will be very easy to convert. So let us see some examples. Right, so let us go from binary to hex. So say the binary number is 1 0 0 1 1 1 1 1 0 1 0 1. So now let us convert this into hex. So what is this easiest way? Just make a group of 4. So let this be a group of 4. 1 2 3 4 and 1 2 3 4. So you can use the table if you, still can't memorize, but if you already have this in your mind, then simply you can convert it. So what is this? So 0 1 0 1. What is this number?
5.
5.
5, sir.
What is this?
So,
F.
F.
Exactly, F. And what is 1 0
Sir,
0 1?
9.
9. So the equivalent hex is 9F5. All right. This is your in hex. Okay. Let us take. Now let us do the opposite. That is hex to bin. That is also very easy. I know. Hex to binary. All right. So let us take any hex number. Okay. So let the hex number be A01. So what is the binary form of A? What is the binary of A?
1 0 1 0.
Yes, sir.
1 0 1 0.
1
What is
0.
the binary of 0?
So 0 0 0 0.
Exactly. Remember, always represent in 4 bits. Okay. And what is
Yes,
the
sir.
binary of 1?
So 0 0 0 1.
0 0 0 1. So all these are very simple. So your A01 in hex will be equivalent to 1 0 1 0 0 0 0 0 and 0 0 0 1 in binary. So is it clear up to this? Binary to hex, hex to binary?
Yes, sir.
Okay. So now let's see how much we have remembered. Okay. Now let us try to do something, that is, let us try to do decimal to hex. Tell me, how will you do it?
Sir, first we will convert into binary, then.
Okay, that is one of the way, and that is the way we'll follow. There are other ways as well. You may follow any method you want, but the
Dividing by 16.
yeah, exactly. That is the other method. You may try it on your own, but we will follow the method. That is, we will not. I will try not to use any new method. The previous methods that we have learned, we will try to use those methods. And what is the simplest method? Convert decimal to binary and then from binary to hex. So let's take an example. Say the number is 45, 10. So now I need to convert 45 into binary first. Now, how can we convert? Do you remember the process of using weights?
Yes, sir. Sir, we will take the near weight of 45.
So which one? Sir, tell me which one will we take?
So 32.
Exactly. We will use 32, 16, 8, 4, 2, and 1. And 1. All right.
Yes, sir.
So do I need 32? Yes.
Yes,
do
sir.
I need 16?
No, sir.
No. Do I need 8?
Yes, sir.
Okay. Do I need 4?
Yes, sir.
Yes, sir.
Definitely. Do I need a 2?
No, sir.
No, sir.
Do I need a 1?
Yes, sir.
Simple. So if you add now, you will see 32 plus 0 plus 8 plus 4 plus 0 plus 1 will give you 45, and this is your binary 1 0 1 1 0 1. So we have already got the binary.
Yes, sir.
Now we need to divide it in 4 bits, right? So 1 0 1 1 will make a group, but then I have got only 0 and 1. So what can I do?
Sir, we will go from left and take 4.
We'll
So
just
go
take-
from right, sir. Go from right, sir.
That's it. We'll
And-
take these are extra zeros, remember. So we
Yes,
added
sir.
extra zeros, okay? So what is 1 1 0 1?
It's a D.
Exactly, D. And
Yes,
what
sir.
is 0 0 1 0?
2.
Sir, 2.
So your finally, so 45 10, if you convert to hex, your answer will be 2D in hex. Okay, so any confusion?
No, sir.
So can you do all these things?
Yes, sir.
All right. So let us go with another one. That is just the reverse one. That is from hex to dex. Same thing. We will again convert from hex to binary and then from binary to decimal. So let's take a number, say 6B2, that is in 16 bits. So let us do directly. So what is the binary of 6?
110 0110.
Exactly, 0 1 1 0. Then what is the binary of B?
Sir, 1 1.
BR binary 1 1
So 0 0 1 1.
1 0 1 1.
1 0 1 1.
Okay, and what is the binary of 2? 0 0 1 0. So this is what you get when you convert from hex to binary. Then tell me, what is our process? How can we convert from binary to decimal? By using weights, definitely.
Yes, sir.
So how can we do? So how many now we need? 1 2 3 4 5 6 7 8 9 10 11 12. So we have got 12 bits. So start with 1, then 2, 4, 8, 16, 32. After 32 is 64. What is there after 64?
So 128.
128. Then 256. Then
Yes, sir. Sir, 512.
512. Do we need to go any higher?
1 2 3 4 5 6 7 8 9 10. Yes, sir.
So the last one is 1024. Right? So rest of the thing is, I think, okay, now tell me, now what will we do?
Sir, I think we need to go to 2048 because we have 12 bits.
Okay. So if you go for 2048, yeah, we need to go for up to 2048, right? Okay. So now what, these are your weights, right? So
So we
these are-
don't need it, sir. We have 0 there.
I know it's better if we keep it. It becomes easier for others to understand. If you get that point, that is also fine. So let
Yes,
us
sir.
just write the digits. So 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 1, 0. Okay. So if we simply multiply and add. So 0 into that is 0 plus 1, 0, 2, 4 plus 5, 1. 2 plus 0 plus 128 plus 0 plus 32 plus 16 0 0 2 0. How much do we get?
Sir, we need to
1714, sir.
Did you convert or did you actually add?
Sir, he added, sir.
Okay, good. All right. So finally, what is our answer? If we have hex number 6b2, then the decimal representative is 171410.
Yes, sir.
So these were all about your conversion, and I believe it is okay. Any doubt, any confusion up to this? Is it clear to all of you?
Yes, sir.
So if I give you any type of conversion between binary, decimal, and hex, I believe all of you can do it, right?
Yes, sir.
Yes,
Inshallah.
Okay. So let us go to a new one, that is no more number system. We already have enough number system. These are the 3 number systems that we need. So now let us go for binary addition. I believe all of you already know, but still, as I said, we will just recall. Okay, so say we go for a plus b. If we go for a plus b, there may be 2 scenarios. We may have a carry and we will have a sum. Okay. So if a plus b is 0 plus 0, will there be any carry?
No, sir.
So this will be 0 and the sum will also be 0. If we go for 0 plus 1, there will be no carry, sum will be 1. 1 plus 0, again no carry, sum will be 1. If we go for 1 plus 1, there will be a carry and sum will be 0.
Sum 1. Yes, sir. Sum 0.
See here. So all of you already know. So let us do a binary addition. Yeah. So let's take a simple example because it doesn't matter if we make it complicated. The process remains same. Okay. So let's add it. So 1 0 1 1. We'll add it 1 1 1. If you don't have anything, you may add a simple 0 to make it easier. So 1 plus 1, my sum will be 0. Carry
0.
will be 1. So 1 plus
Yes, sir.
1 again 0. With 0, there will be another 1. So it will be 1 and there will be a carry,
Carry.
right?
Yes, sir.
1 plus 1, again the sum is 0 and there will be another carry. 1 plus 1 0 and there is another carry that will just directly come down and this is your sum.
Yes, sir.
Is it understood to everyone? Binary addition.
Yes, sir.
You may simply try in decimal also. So what is the decimal of 1011?
Sir, so 11.
Exactly 11.
18, sir.
18.
Yeah,
That's
11 plus 7, you get 18. That is exactly this answer.
Yes, sir.
All right, so we know this thing. So binary addition is also done. I believe all of you at least remember our next topic, that is 2's complement, right? You remember?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, let's see. So if we want to make a 2's complement of this number, what will we do first?
Sir, we will write for 0 for 1 and 1 for zeros.
Exactly, we'll reverse all the bits and that's how we will find the 1's complement, right?
Yes, sir.
So 1 0 0 0 1 1 0. So this is our
1's complement.
1's complement. So what we do after this?
Sir, we will add 1 with the 1's
We
complement.
will add 1 and that will give us our 2's complement. So the addition become very easy because we got a 0, so nothing complicated. Okay, fine. So this is our 2's complement. Clear up to this?
Yes, sir.
Yes, sir.
Now let's see another topic, that is hex addition. Are you guys familiar with this hex addition?
No, sir.
Let's take 2 numbers. Okay, let's take 2 hex numbers. Say add 2 3 d9 plus, okay, I have add 2 3 d9 and 9 4 b e. Okay. So let us follow the conventional method, that is 2 3 d9 9 4 b e. All right, so we need to add. So start from this left, right hand side. So 9 plus e.
So 9 plus e is sir 20 23. Yes, sir.
So 23. So what
Yes,
will you
sir.
write over here?
Sir, I think we will write, sir,
We'll
7.
let 3 and take 2.
So 23 minus 16, 9.
16, yes, sir.
Exactly,
Yes, sir.
exactly. 23 minus 16. How much do you get?
9.
Sir,
Sorry,
9, sir, 9.
7.
7, sir.
Okay. Exactly. You have got
Yes,
a
sir.
7, and of course there will be a carry. So you
Yes,
will
sir.
have a carry over here.
1, sir.
Exactly. Yeah. So what is our next step? 1
Sir,
plus
1 plus D
B
plus B.
plus B. How much do you get?
13 plus 11, 24, 24 plus 1, sir. 25, I
So
think.
what will we do again? We will do the same thing. 25 minus 16. We will get 9. with
9.
A carry. So there will be a carry, and we'll write over here 9.
Yes, sir.
So what is our next process? 1 plus 3 plus 4. How much do we get?
Sir, 8.
8. So there is no carry, no complication. Just
Yes,
put
sir.
8. And 9 plus 2 is how much? Last one.
Sir, sir, B.
Exactly, B. So if you add, this is your answer. Did all of you understand?
Yes, sir.
See, this analogy is same to your decimal number system. If you had a decimal number system, you applied the same analogy. Instead of 16, you just had 10. But we normally do not have that in our mind because we readily can do that. But since we are not that habituated with hex, I just showed you. So if I give you any addition now, I believe all of you can do that, right?
Inshallah, sir.
Yeah. All right. So what do you think is our next topic?
Sir, binary subtraction.
Binary subtraction we do not need because we have got 2's complement, right? So we can
Yes,
simply make 2's complement and add. So what is the next topic?
Sir, multiplication.
Hex subtraction.
Hex subtraction.
So let's go for hex subtraction. So say the question is 5, 9, F minus 2, B, 8. Okay. So let's write 5, 9, F and 2 and B and 8. And let us do subtraction. So what is the first thing? That is F minus 8. How much do we get?
Sir, 7.
So there is no complication, just directly write 7. Now we get 9 minus B. Now what will happen?
We'll add 16 to 9 and then subtract.
Exactly. So what
Yes,
we have
sir.
to do, we have to add 16 with 9, sorry, then subtract from B. So what will we get? In decimal, we will get 14. If you convert that into hex, you will get an E, isn't
E.
it?
Yes, sir.
So we will put an E, and what will happen? This one will automatically become 4, isn't it? Because we have taken a 1 carry. Is this question understood?
Yes, sir.
See, we
Yes.
added 16 with 9, right? So if we take 16 from here, this one will automatically decrease to 1. So 4 minus 2, we have a 2, a simple 2. So this is your answer. 2 is 7. So is addition and subtraction clear to all of you?
Yes, sir.
Of course, you can do that using your calculator. I know that. But as engineers, at least you should know the mechanism so that even if you do not have calculator, and remember, whenever you are using calculator or something like that, there is always a limit as to how many digits it can handle. Okay, there is always a limit, but with human being, that limit is not there. So even if you want to push the limit or you want to do something that is beyond the capacity of a calculator, you at least need to know the mechanism. Once you know the mechanism, then for your benefit, for your simplicity, definitely you can use the calculator. But before using the calculator, make sure you know the mechanism. All right, I believe all of you know about ASCII, so I will not go for ASCII. You know binary logic level, right? Okay, one of the question, why do we use binary in computer system? Because this is the simplest way in which 2 voltage levels can be represented. Okay, so that is the simplest way in which 2 voltage. Remember, normally we say that 0 volt is equivalent to binary logic 0 and 5 volt is equivalent to binary logic 1. But there is actually a threshold, like in normal standard from 3 to 5 volt. That is known as binary logic level 1. Okay, from 3 to 5 volt. Any voltage between 3 to 5 is represented as binary logic level 1, and any voltage around 0 but less than 1 is represented by binary logic 0. Please do not ask me what will happen if we have 2 and 1. Okay, because we normally do not have and we get errors in those cases. All right, our next topic is gates. I believe all of you already know all the gates. You have done সাগর স্যারের কোর্সের নাম কি ছিল?
Sir, digital logic design, DLD.
Exactly, DLD. You have done DLD, right?
Yes, sir.
All of you should know this thing very clearly. Okay. Let us go for, let's keep it like this. Let us go for AND gate. So in case of AND gate, we have an input and we have X and Y. Okay. So 0 0, what we get?
0.
0 1 is 0, 1 0 0, and 1 1 is 1. And this is your AND gate, right? This is your X, this is your Y, this is your X and Y. Is it okay up to this? Similarly, let us go for OR X Y X or Y. So 0 0 you will get 0, 0 1 1, 1 0 1, and 1 1 is also 1.
Yes, sir.
And how will it look? It will look something like this. You have definitely two inputs, X and Y. Any confusion up to this?
Sir.
Okay up to this?
Yes, sir.
Right. So what is your next gate?
Sir, NOT gate,
Not gate or inverter.
inverter.
Exactly, not gate or inverter, whatever you say. So normally the name we use is inverter or logical inverter. So you have a single input in this case and the symbol is not X. So very easy. If you have got a 0, I've got a 1, I've got a 1, I've got a 0. So what is the symbol? Symbol is also very simple. This is your not X. So this is your X and this is your not X. The next one is definitely XOR. So if we go for XOR, again we will have two inputs X, Y, and this will be X XOR Y. Alright, so 0 0, it will be 0 0 or 1 1, 1 or 0 1, 1 and 1 is 0. So how do you draw a XOR gate? This is your X or Y. Just put another one over here. Is it okay? XOR gate.
Yes, sir.
Then there is NAND, that is AND. After AND there is a NOT. So I will not go for the truth table, I'll just draw the diagram. So this is your NAND gate, that is NAND, and we have got an NOR gate. So your NOR gate is something like this, and this is your NOR gate. All right, so we covered AND, OR, inverter, XOR, NAND, NOR. Any query up to this? Any doubt?
No, sir.
Okay. Next, we will go for a. Is it okay? I mean, can we continue, right? Because there had been nothing too complicated, so we can continue, isn't it?
Yes, sir.
So let's try to make an adder. So we already know this thing that 0 plus 0. There can be two things. One is carry, another is sum. So if you go for 0 plus 0, carry is 0, sum is also 0. 0 plus 1, carry is 0, sum is 1. 1 plus 0 is 0, sum is 1. 1 plus 1, carry is 1, sum is 0. All right, tell me, the output of carry looks like which gate?
Zor.
Assume these are inputs.
Sir,
Output
and
of
get.
Zor gate.
Sir,
AND
carry
or
sir and
XOR?
get. Carry
I'm
sir
asking-
and get.
Sir, and get, sir. Carry and get.
Exactly. Carry is AND. See, 0 and 0 is 0, 0 and 1 is 0, 1 and 0 is 1, 1 and 1 is 1. And what is the sum?
So it's XOR get.
Zor get, sir. Yes, sir.
Exactly. So, okay. So very simple. So how can you design this thing? Just add a AND gate and a XOR gate. So how do you go for a XOR gate? This is your XOR gate. This is your input, say X and Y. And the output you get is what? Sum or carry?
Sir, that is sum, sir.
Exactly. Sum. With this, you need to go for an AND gate. If you go for an AND gate, this is your carry. Just take the two inputs from here. Whenever you take inputs, make sure you put a dot. You already know from DLD. All right. So this is your half adder, isn't it?
Yes, sir.
So you can use or you can add two half adders to make a full adder. The only difference is we need an extra OR gate because there might be carry from any digit. So in a full adder, we can add 3 digits. So we need an extra OR gate. I believe you can do that. So I will not do that. Just adding two half adder will give you a full adder. So these were pretty much all that I wanted to cover. The next thing we will discuss in the next class. That is, we'll go inside the computer. What is there? So maybe we'll start from next class. So this all will be enough for today's class, I believe. Okay. So did you understand today's class?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Good.
Yes, sir.
I think you may stop recording. I'll just take the attendance now.